What's going on, guys? In this video we are going to see an example of inverse Laplace transform. In this particular problem we have asked to find the inverse Laplace transform for this given function. Now in order to do that, first of all you have to look at the pattern. If you look at this pattern, this is matching exactly like this, like almost like this. So when we have this kind of pattern, we can do the inverse Laplace transform using this e power at cos bt and e power at sin bt. First of all we have to get this pattern. Now let's see how we can get this pattern for this given function. Here we have s plus 3. Okay, now first let's keep the numerator as it is. So this is going to be just s plus 3. And if you look at this denominator, we have s square plus 4s plus 13. But in order to transfer this one into this pattern, we had to have s minus a square plus b square. But this is almost like near to a perfect square trinomial, but there's the last term is not matching to the perfect square trinomial, because if you think about this, we have to have a square plus 2ab plus b square. In our case we have a square plus 2ab pattern, but we don't have the b square pattern. So to get that one, what we can do is we can like add a number here. So this is going to be s square plus 4s plus 4. This is a perfect square trinomial, but when we add a number we have to subtract. So here we are going to have plus 13 minus 4. So if you simplify this one, this is going to become s plus 3 over s, like instead of s square plus 4s plus 4, we can write s plus 2 whole square, because this is a perfect square trinomial. So this is going to turn into s plus 2 whole square, and 13 minus 4, that's going to become 9, right? Let's compare this pattern with this one. Here we have s minus a, and in the denominator we have to have s minus a square. So we can write this one as, we have to have negative sign, right? So to turn this one into negative sign, we can write this one as s plus 3 over s minus minus 2 whole square. Now we have this pattern, and also we have to have b square. This 9 is equal to 3 square, so we can write this one as 3 square. But in the numerator we have to have s minus a. Here we have s minus a square, so we have to have s minus minus 2. So this is going to be s minus minus 2. Here we are adding 2. So if we add 2, we have to subtract 2, and this 3 remains the same, because we just have to bring this s minus a to the top 2, because this is our s minus a, right? So we have to have the same number on the numerator. That's why we have this one here. Now let's copy the denominator. Denominator is going to be s minus minus 2 whole square plus 3 square, and if you add these two together, this is going to become s minus minus 2, and then we are going to have minus 2 plus 3, that's going to become just plus 1, and in the denominator we are going to have s minus minus 2 whole square plus 3 square. Now if you look at this one, this is now almost matching this one until this part, right? Until except this one, we have exactly same pattern, but this one is not correct. Like when we have this one, we cannot do anything, so we have to do something for this one. So what we can do is we can separate this one. Let's go ahead and do that here. Here we are going to separate this one. So when we separate this one, the denominator is going to be the whole thing. So we are going to have s minus minus 2 over s minus minus 2 whole square plus 3 square, and if we separate this one, this is going to become 1 over s minus minus 2 whole square plus 3 square. Okay, now if you look at the second one, it is almost matching this e power at sin bt, but the thing is we have to have b on the top, but in our case we don't have b, we have 1, b is 3, because this value is b, right? This value here, this is our b value. We have to have the same value on top in order to transfer this one into this pattern. Now to transfer, what we can do is we can multiply this one with 3 over 3, because if we multiply we have to divide, so we multiply this one by 3 over 3. In that way we will get s minus minus 2 over s minus minus 2 whole square plus 3 square. But this 1 over 3 we have to get out of this one, because we only have to have 3, like b on top, right? This 3 doesn't do anything. So this 1 over 3 is going to be in the front, and then we are going to have 3 over s minus minus 2 whole square plus 3 square. Now we can do the Laplace transformation. So our Laplace transformation function is going to be, for this one, for the first one, our a value is going to be negative 2 because this is our a value, and b value is going to be 3 because this is our b value. B is equal to 3. And for the second one, we have a value that's negative 2, and here also b value is equal to 3. Okay, now we can go ahead and do the Laplace transformation, and when we do that, this is going to turn into e power at, and a is negative 2, so this is going to be negative 2t, and then cos bt, cos b is 3, so this is going to be 3t, and then here we are going to have plus 1 over 3, and then e power at, in our case a is equal to negative 2, so this is going to be e power negative 2t, and then we are going to have sine bt, so this is going to be sine b is 3, so this is going to be 3t, and this is going to be our Laplace transformed function. And that's how we do the Laplace transformation. I hope this helps. Thanks for watching. That's how we do the inverse Laplace transformation. Okay, this is inverse Laplace transformation.